Assalamualaikum and good morning, everyone. How are you today? So, are you still okay, guys? Are you happy to
Okay.
okay?
Teacher.
Hope all of you can still focus in my class because it's still early on in morning, right? Okay, all right. But before that, let's recite doa for enlightening our hearts kita berfatihah, and for non-Muslim, you can also pray your own doa. Bismillah. Ameen. So before we start our class today, I would like to introduce a few teachers that will teach all of you for today. Which is me, myself, Teacher Husna, and we have Teacher Akila and also Teacher Munirah for today. Okay, today we will continue our lesson on second chapter, which is about force and motion on subtopic linear motion. But before that, let's hear song slow and fast before I explain further.
I go fast, 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 fast. I go fast, 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 so I'll never be the last. I'm driving in my car. I'm driving, and nothing is too far. No! I go slow ho ho, slow ho ho, slow ho ho. I go slow ho ho, so I'm always last in row. Sitting, I'm sitting, I'm sitting on a snail. I'm sitting, I'm sitting, he brings me up the hill. Why don't you sing along, sing along, sing along? Why don't you sing along with our descendant sweet song?
Okay, guys. So the video that you watch is very related to our lesson for today. So this is the learning outcome for our topics, which is I expected that you can describe and distinguish between three states of linear motion of an object, and also you can understand each term that we will use under the linear motion subtopic, which is distance, displacement, speed, velocity, acceleration, and decelerations. And also you will be able to differentiate on each of the terms given and know how to solve the problem in those that the equation given. So for this part, I have made a simple summary for this topic, which is in this topic, all of you learn about the definition of linear motion, and then the fraction of this subtopic. First, in the 2.1.1, you will learn about the types of linear motion in three following states, which is stationary or rest conditions, uniform velocity, and non-uniform velocity that will explained by me. While for the second fraction 2.1.2, which is determine the following terms like distance, displacement, speed, velocity, acceleration, and deceleration will be explained by teacher Munira. The third, which is 2.1.3, about the solving the problem involving explained by the teacher. So, motion of linear motion, which is the linear motion described well as the motion in a straight line. So, linear motion also can be described in a terms, which is we use distance, displacement, speed, velocity, and acceleration. In this topic, according to the Newton first, principle of inertia, an object with no net force acting on it will either remain at rest or continue to move with uniform speed in a straight line, according to its initial condition of motion. So, in this topic, you can see when the okay, example I like give it in a linear motion. Free stays in a linear motion, which is first stationary or rest. Okay, example like if you see a taxi waiting for a passenger in a slot, the position of a taxi that remains unchanged with time, we say that the taxi in a stationary or rest condition. But second, is uniform velocity. Example, like if you see the car is moving at uniform velocity because its rate of change of the displacement remains the same. So if you see the car moving at the same time at the same displacement, so we call it in a uniform velocity. But for a non-uniform velocity, uh, the car is moving the rate of change of displacement is increasing, which is there are accelerations here. So the velocity is non-uniform. So now teacher Moon will explain about the terms that we use in motion.
Hi class, can you all hear me?
Yes, teacher. Yes, teacher.
Okay, I'm teacher Munira. And the objective that I'll be covering today is the second objective, which is to determine distance and displacement, velocity, acceleration. See what is distance and displacement. Distance is the length of the path taken by an object, whereas displacement is simply the distance between where the object started and where it ended up. Okay, so as you can see in the diagram below, the boy walked from A to B to C to D and back to A. So his distance would be 50 meters. How do you get 50 meters? Add up all the length that he traveled. And displacement would be 0 meters because his initial position, his final position is the same as the initial position. So his displacement would be 0 meters. Next. Okay, now we will look at the formulas in velocity. First is speed. What is speed? Speed is rate of change of distance traveled. So the formula would be distance traveled divided by time taken. And SI unit is meter per second. Next is velocity. Velocity is of displacement. So the formula would be displacement divided by time taken, and the SI would be distance. And finally, acceleration is rate of change of velocity. And the formula would be final velocity minus initial velocity divided by time taken plus the change of velocity. And the SI unit would be meter per second square. Next. Okay, now I'll show you one example and we will do some questions so that you can understand better. Okay, so figure below shows Ahmad runs from A to B and then back to C. The total time taken by Ahmad is 20 seconds. So now you have to determine the distance, displacement, speed, and velocity. Next. Okay, distance. Okay, the distance is length of route covered. So the answer you have to plus AB plus BC. This is 100 meter plus 20 meters, so you will get 100 meters for the distance. And for the displacement, displacement is distance between initial position and the final position in a specific direction. Where in this case, you have to consider the distance. Still the same as plus BC, but this is that opposite direction you do 100 meter plus negative 20 meters. So you will get 50 meters the right. Next. Okay, for the speed, speed is reduction to distance traveled. The distance covered divided by time taken. Distance traveled is 120 meters and time taken is 20 seconds. So the speed would be 6 meter per second. And for velocity, displacement divided by time taken. Displacement is 80 meter divided by time taken, which is 20 seconds. So you get 4 meter per second to the right. Next slide. Okay, now I'll show you about ticker timer.
The velocity and acceleration of an object can be measured using a ticker tape timer. The ticker tape timer consists of a steel strip that vibrates 50 times a second. This enables the vibrating steel strip to make 50 dots per second on the ticker tape being pulled through it. The constant time interval between two successive dots on the ticker tape is called 1 tick. 1 tick is equal to 1 over 50, or 0.02 second. The distance between successive dots on a ticker tape depends on the velocity of the tape. If the tape moves quickly, the dots are far apart. If the tape moves slowly, the dots are close to each other. Changing distance between successive dots on the ticker tape indicates a changing velocity, and thereby indicates that the ticker tape is accelerating or decelerating. A shows uniform distance between successive dots for a uniform velocity. B shows ticker tape example for objects moving with an accelerated motion. C shows ticker tape for objects moving with uniform deceleration. Ticker tape charts can be constructed by cutting the ticker tape into lengths, with an equal number of dots on each length, and sticking the lengths side by side in the same order that they were on the whole tape. Ticker tape charts are usually constructed with 10 tick lengths. Each 10 tick length shows the distance covered in 0.2 second, and is therefore a measure of the average velocity during the time interval of 0.2 seconds. The shape of the ticker tape chart shows how the velocity varies at successive time intervals. For example, the length of 10 tick increases uniformly. Motion with velocity increases uniformly, that is, motion with uniform acceleration. In this example, motion with velocity that decreases uniformly, that is, motion with uniform deceleration. The ticker tape chart shows all the 10 tick lengths are of the same length. This means that the motion with uniform velocity or zero acceleration.
Okay, that's all for my part today. I will pass to Teacher Akila.
Okay, hi, I'm Teacher Akila. Can you hear me?
Yes, teacher.
Yes.
Are you okay today?
Okay, teacher.
Do you
Okay,
understand
teacher.
what Teacher Munira and also Teacher Hazwani have teach you?
Yes.
Yes.
Good. Okay, now we are going to solving problem of linear motion using linear motion equation. Okay, there are four equations that you need to learn. The first one is V equals to U plus AT. The second is S equals to half U plus V times to the T. The third is S equals to half AT squared plus UT, and the last one is V squared plus U squared plus 2AS. Okay. We are going to derive how this formula has. So the first one, V equals to U plus AT. We are got this from formula of acceleration from A equals to final velocity minus initial velocity divide by the time, and you will get V equals to U plus AT. Okay, so the second is S equals to half U plus V times to the T. This is the formula of displacement. So displacement is the average of velocity times to the time. The first form you may be not comfortable with it, but the second form is maybe you are comfortable with it because it show you that U plus V is divided by 2. Okay, the third equation, S equals to half AT squared plus UT, it is from the formula of displacement where we take it half U plus V times to the T and we substitute V plus U plus AT, V equals to U plus AT. So, and you into the equation of displacement and you will get S equals to half AT squared plus UT. Okay, the fourth one is V squared plus V squared equals to U squared plus 2AS. When you got from the equation number 1, V equals to U plus AT, and we square it, and we will get V squared equals to U squared plus 2A factorized with UT plus half AT squared. Half AT squared plus UT is from the formula of displacement. And from here, we substitute the equation of number 3 we have learned just now. And we get V squared equals to U squared plus 2AS. Okay, here is the example 1. Example 1 is as a sport car moves along a straight track, its velocity is 40 meters per second. After 3 seconds, the sport car has reached 50 meters per second. Calculate its displacement. How to calculate it? Are you understand?
Yes.
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 Okay,
Use
I'm
the
sure.
formula.
Yes, use the formula. So how to use the formula? I will show you step by step, okay?
Okay, teacher.
Okay, step by step. The step 1 is to identify the number have involved. So, what is the number have you seen in this question?
40,
40.
3 second and also
50 is the
50
second.
second.
Okay, 40, 3 second and 50 meter per second. Okay, now step 2. Identify the word that show velocity, displacement, speed, time and acceleration. Okay, for the 40 meter per second, what it is? It is show that it
Velocity.
velocity. Okay. This is the initial velocity because it said it start from the velocity start of the sport car is 40 meter per second. And the final he has said that the car has reached at 50 meter per second. That means final velocity is 50 meter per second. And the time is after 3 seconds. Okay, so it has said here calculate its displacement. So that means this question want displacement, right?
Yes.
So which formula we are going to use? We have U, we have V, we have T, we have S.
V minus U divided by T. Here.
No. Okay. So we have the formula of
Plus
displacement.
V
Yes, right. U plus V divided by 2 times to the T. Okay, we have
time.
from here we can get the displacement as we only use the formula of displacement. So we choose our right equation to enter in our formula. And finally we will get 135 meter. Do you understand?
Meter. Yes, teacher.
Yes.
Okay. Next example. Okay. Maria rides a bicycle at velocity 8 meter per second. He brakes suddenly and stops after a distance of 2 meter. What the acceleration of Maria and her bicycle? So what the first one we need to identify the number that have involved. What number?
8.
8.
8.
8 meter and also 2 meter distance.
2 meter distance. Only that?
Yes, teacher, only two numbers.
Okay, only two numbers. And then we need to identify the formula, the words of velocity, times, acceleration, and something else. Okay. Can you see here that I have highlight to you the initial velocity, it is 8 meter per second because he said he ride the bicycle, right? And the final velocity, how I get with 0 meter per second. When he said it is break, she is break suddenly, that's mean he stop, and that's mean the velocity is 0 meter per second. Do you understand?
Yes,
Yes,
teacher.
teacher.
Yes.
And then the distance is 2 meter. That means the displacement is 2 meter. And what is the acceleration? So what the question wants is acceleration A. Okay, what formula we are going to use? We have U, we have V, we have S, and we need A.
I know, teacher.
What? What, Atira?
V square equals to U square plus 2AS.
Right, congrats. So you are so great. Okay, v squared equals to u squared plus 2as. We are going to use this formula as we have the value of v, u, and also s. We only need a. Okay, so the final answer we will get is negative 16
Negative
meter
16 meter per
Negative
second.
16.
second. Okay. Note that the negative value shows Maria accelerate 16 meter per second in opposite direction to the motion of the bicycle. Okay, this is the question for you. This is SpongeBob. He is taking driving test. He need to drive from Jellyfish Field to Bikini Bottom with displacement 30 kilometer within 2 hours to get a driving license. SpongeBob drive his car with Patrick at velocity 10 km per hour. What acceleration that he need to accelerate his car to arrive at Bikini Bottom within 2 hours? So here, what is the value, the number that has involved?
30
30
kilometer,
kilometers.
30 kilometer,
2
2
hours,
2
hours.
2
hours.
hours,
10 kilo, 10
10
kilometer
kilometer
per
per
hour.
hour.
Per hour.
Okay, so we can see that time we have 2 hours, displacement we have 30 kilometer, and initial value we have 10 kilometer per hour. And what we need is the acceleration. We have T, we have S, and also we have U. We need A. We doesn't have B to use V squared equals to U squared plus 2AS. But we have T. So what formula we are going to use?
S.
S.
S equal to half AT squared plus UT.
Yes, congrats! You are so great! Yes, the formula is we are using the displacement as equals to half AT squared plus UT. When we have displacement, we have time, and also we have initial velocity. We only need acceleration. So when we are calculate this, we will get that acceleration is 5 kilometer per hour. So SpongeBob has got his driver license and he said thank you. Next, we
Welcome.
are going to game time. I'm going to give to Teacher Husna. Teacher Husna, are you okay with that?
Okay, okay.
Okay. Teacher Husna, can
Okay.
start.
So right now we will play game. Okay. Firstly, in this game, Teacher Akila will screen your name on the board. So when you get when your name is is chosen, so you need to answer the question given. So if you was chosen first, so you will answer the first question. Can you understand?
Yes,
Yes,
teacher.
Yes, teacher.
So we will start. Okay,
We
Teacher
will
Kila.
start. Okay. Wait for a while. Okay. I'm going to spin. Oh yes. Warzia is going to start.
Satu.
So the question is
Okay. The question is the acceleration is what the answer?
the rate of change of velocity.
Yeah.
Congrats, Warzia. You have got it right. Okay, next.
Good. Okay, so the second person.
The second person. Kausa is the one.
Okay. The second question is a person walks 6 meter west, 3 meter east, and 2 meter west. What is his total displacement? So what is the answer, Kausa?
Wait a minute, teacher.
It's okay. Take
The
your
answer
time to
is
calculate.
5 meter.
5 meter.
5 meter,
Correct.
teacher.
It is
Yeah,
correct.
right.
Yes.
Yay. Yay.
Yeah. So okay, we see next question. Okay, which person?
Okay, the third one is Warzia again. So Warzia, you have to turn for the third question.
I'm so famous, teacher.
So what is the question? Okay, a bird fly with an average velocity of 13.4 meter per second for 92 meter. Time does it take the bird to?
Teacher Hazwani, can you hear me, Teacher Hazwani? It's okay. I will take the question here. Okay, Teacher Hazwani. Okay, for Warzia, you have going to answer the question. Can you answer the question?
Wait, teacher.
It's okay. You can take time to calculate it.
6.9 seconds.
6.9 second. It is correct, Munira Begum. Teacher Munira? Teacher Munira?
What's the answer?
Warzia have
6.9
said
seconds.
6.9 second.
Okay.
It-
Oh yeah, it's right. It's right.
It's right. Okay, congrats, Warzia.
Yay.
I'm so clever, teacher.
Yes, you are
Yes.
so clever. Okay, the fourth question.
The next person.
Okay, Kausa again.
So the question is, it takes a plane 35 seconds to reach a safe takeoff speed of 67 meters per second. What is the plane's acceleration? So you can calculate using the equation that has been teach by Teacher Akila before. So what's the answer that you get, Hausa?
Um, wait, teacher.
Alright.
Eh?
Okay, I got the answer. The answer is 1.91 meter per second square. Is it
Yeah,
correct?
yes, that's correct.
That's correct. Congrats,
Mm.
Kausa. You are so clever. You must got math, physics A, right?
Yeah.
Thank you, teacher.
Hausa best student, teacher.
Wow. Okay, we have the last question.
So the last question.
Okay, Hafiz. We have Hafiz. Where is
Okay.
Hafiz?
So the question is, find the speed of a person who covers 20 kilometer in 5 hours. So what's the answer, please?
4 kilometer per hour, teacher.
Yeah.
Kilometer per hour.
Yeah, that's my answer.
Is correct answer? It is
Yes.
correct answer?
Yeah, but yeah.
Yes.
Oh, okay. So, okay, right now we have Kahoot time. So for Kahoot, you can open your Kahoot is the game pin that you can you can enter our Kahoot. Okay, right now we are going to wait for Warzia and also Shamimi.
Conscious. Okay, go.
Okay, we have 5
See my name?
participants here. Okay, can we start now? Okay, the total path length covered by a journey is known as what it is. One person not I have answered it.
Sorry, teacher, I cannot see you.
Choose the one on your screen. They have 4 cards, right?
Oh,
Okay.
sign up.
Okay, Hafiz is the number 1. Next question, athlete is running 200 meter along a straight track is an example of the red one is circular motion, the yellow one is rectilinear motion, the blue one is linear motion, and the other is none of the option. Choose the number. Okay.
Woo! I got it.
Wow, Hafiz. Okay.
Teacher, my
Question.
internet is so slow.
Oh, it is okay because this is the exercise for you guys, and if you have limited internet, then it is okay. We can do it later.
Motion in a straight line is given by. Okay, 3% have answered it. Wow. Hafiz has got the number one still. What is the difference of
teacher.
distance and displacement? You can choose. I'm going to short the time as we have 5 minutes to stop our class. I'm skip. Okay, 3% have choose the right answer. Okay, the answer is displacement can be equal to 0. We will do it again later, okay? Okay, Hafiz is still the number one. Okay, the fifth question is an astronaut travel at a speed 400 meter per second for 250 seconds. What is the total distance he traveled? You can answer it quickly because I'm going to skip it. Okay, one person only have choose the right answer. It is 100 meter per second. 100,000 meter per second. 100,000 meter. I'm sorry. Hafiz is the number one.
Sorry,
Last
teacher,
question.
but where's my name? Oh?
His name there is at the bottom. Okay. A horse follow a dangling carrot for 20 meter. If it took her 50 seconds to reach it, what was her average velocity? I'm going to skip the time. Okay, there is 2% have I got the answer. It is 0.4 meter per second. So Kausa is the number 3. Atira is the number 2. And the first one is Hafiz. Congrats,
Eh,
Hafiz.
happy.
Okay.
Woo.
And okay, next. I'm going to stop my sharing. Okay, that's all for our today lesson. I will pass to Teacher Munira to for the last season.
Okay, so for today's conclusion, you have learned three states of linear motion of an object with teacher Husna. And also you know the terms and the difference between distance and displacement, speed and velocity, and acceleration and deceleration, which was explained by teacher Munira. And also from teacher Akila, she explained to you a few formulas on how to solve problems involving linear motion. Okay, so that's all for today. And you have homework on page 36. You can try all the questions. See you
Okay,
guys in the
thank you.
next class.
Thank you, Teacher Husna. Thank you, Teacher Munira.
Thank
Thank
you,
you.
everyone.
Thank you, everyone.